Yes, you have to operate with this one first, and then to move one by one here. When you operate with this factor, what will be the idea here? 1 by, suppose it is generally m here, d minus m d dash f of x comma y. If you operate with any one of the factor here, then what will be the procedure we can follow here? Here you are going to apply Lagrange's linear idea here, Lagrange's linear idea here, where you have to evaluate this one here, where its evaluation takes the following. Let you take it as this one as a unknown here. This one as a unknown f of x comma y is equal to z. This one as unknown f of x comma y equal to z. And what you can get here, d minus m d dash of z cross multiply, that is equal to f of x comma y. Implies this is nothing but dou z by dou x minus m dou z by dou y. Dou z by dou y. This is dou by dou x. This is dou by dou y. This is equal to f of x comma y. F of x comma y. This is of the Lagrange's linear equation. P minus mq is equal to f of x comma y. P minus mq is equal to f of x comma y. Then auxiliary equation is dx by 1 dy by minus m equal to dz by f of x comma y. Dz by f of x comma y. Dz by f of x comma y by Lagrange's linear equation. This is Lagrange's linear equation. Lagrange's linear equation. That idea we can follow. Right. Then if you glove these two here by first two proportions, first two proportions, what you can get here, dx by 1 equal to dy by minus m here. You cross multiply this one here. Y is equal to minus mx plus a. Y is equal to minus mx plus a or a minus mx. Y is equal to a minus mx. That type of idea we can get that. Right. By first two proportion, you can get y is equal to a minus mx formula. First two proportions you can get cross multiply, you can get a minus mx. Then you consider we are interested to find z. What is z? That is the general solution. General solution. Or consider first and third proportion. First and third proportion here, because from this you can write z equal to dz equal to f of x comma y dx here. By first and last proportion. First and last proportion, that is dx by 1 equal to dz by f of x comma y. Okay, dz by f of x comma y. I can write dz is equal to f of x comma y dx. Okay, f of x comma y dx. Integrate. Then you, if you want to integrate with respect to x here, we are purely with respect to x, but here one y involves here. Here x, okay. For now we can replace this y as a minus mx form with the help of first idea here. Okay. First idea here. Substitute y is equal to a minus mx mx. Substitute y is equal to a minus mx. This since by 1. Okay, since by 1. And what you can get here, dz now can be written as f of x comma a minus mx. Okay, purely in terms of x. Everything purely in terms of. Here purely z and here purely x here. Okay, therefore integrate now here. Integrate implies z, you can get as integral x comma a minus mx. Okay, x comma a minus mx dx. This will be the idea. This will be the idea with the some condition with a plus arbitrary constant c, a minus mx. But what you are using here, a minus mx integration, a minus mx integration you are using here. Then after integration, you can replace finally a is equal to y minus mx. A is equal to y plus mx. A is equal to y plus mx. A is equal to y plus mx. Because in the after integration you can get a here, okay? You can get a in the solution here, but in the particular solution there is no constant will involve here, okay? In the particular solution in a complementary function you can use arbitrary function or constant here, but in the particular integral you cannot use any constant, okay? You cannot use any arbitrary constant here. Therefore finally and after integration if you have any a, you have to replace a as again this form here, a is equal to y plus mx. A is equal to y plus mx since by 1 here, since by 1. That will be the idea here. For replace a is equal to y minus mx, y plus mx, we get the general, we get the particular or general solution. We get the particular integral. Get the particular. Because already we identified complementary function that involves arbitrary constant, arbitrary function idea. But particular integral you cannot find, you cannot use any arbitrary constant. Therefore again you have to replace y is equal, a is equal to y plus mx. This will be the idea. So what will be the shortcut procedure we can follow here? Hence 1 by d minus md dash. Suppose your root is in the form d minus, factor is in the form d minus md dash of f of x comma y, f of x comma y. How can you evaluate here? If you want to find z from this, if you want to evaluate this one here, this is taken as a z. This is taken as a z. Then how are writing z here? Integral, immediately you can write integral f of x comma a minus y, you are going to replace by a minus mx. Y, this y you are going to replace by a minus mx. You treat it as this as a, instead of d you think that a m a minus m x instead of d dash x. In that manner you think that here. Therefore what about this factor here? Suppose here d plus m d dash means you can get it as a plus mx form here, okay? A plus mx form. Therefore depends upon this factor relation, you write that a minus mx dx with respect to x here. Then after that, after integration you have to replace again a as a y plus mx, a as a y plus mx form. After integration, any a comes here, you can replace a as a y plus mx form here, okay? Y plus mx. This is a shortcut way you have to think that, think that. For hence 1 minus of this factor, directly you can write here. No need to consider all the Lagrange's linear procedure here. Lagrange's linear procedure, directly you can write 1 by d minus md dash of x comma y. How can you integrate here? If you find this kind of thing here, immediately you operate integration. Then x you replace as it is, y you are replaced by a minus mx form, and then integrate. Then after integration you have to replace a by y plus mx, a by y plus mx. This will be the idea we can follow. Okay, right. This is for any kind of functions, not in the previous 4 types here. If you find the function in the RHS that is not in the form of previous 4 types here. It's not in the form of previous 4 types here. Then you can adopt this idea here. The procedure is very simple. Operate denominator you write as in terms of many factors here. Operate one by one. You first operate this factor, then you can get again f of x comma, because finally you are writing integral as in terms of x comma y. Again you operate this factor, again operate with this factor, and move up to all the factors. All the factors, then you can get the answer. This is the idea. Idea is very simple. If f of x comma y, if you operated, just replace y by a minus mx. Y by a minus mx here. You have to remember this one here. Y by a minus mx here. Then after finally integration, you have to replace a by y plus mx. I think all of you understand this idea in order to evaluate this one. Right. Now we move on to some problems here. Solve with the help of these ideas here. D square minus 5d dash plus 6d dash square of z. Okay, 6d dash square of z is equal to y sin x. Y sin x here. So, d square minus 5d dash plus 6d dash square of z is equal to y sin x. Here product of functions. This is algebraic polynomial. This is trigonometric. The product of function exponential with other product, you know the procedure in the previous type 4. but there's no exponential here. It is only sine or cosine into algebraic polynomial here. Therefore, first find, you can use type 5 procedure. First find complementary function here. Complementary function auxiliary equation is m square minus 5m plus 6 equal to 0. M minus 2, m minus 3. M minus 2, m minus 3 is equal to 0. M is equal to 2 comma 3. Therefore, we have factors in the form of d minus 2d dash, d minus 3d dash. Your factor of this equation is d minus 2d dash, d minus 3d dash. That is the factor. Therefore, CF is equal to pi 1 of y plus 2x plus pi 2 of y plus 3x. Pi 2 of y plus 3x. This will be your CF. Now we are going to concentrate on particular integral. Particular integral that can be written as 1 by phi d d dash. Phi d d dash plus 6d dash square. 6d dash square of y sin x. 6d dash square of y sin x. Now, with the help of these factors, m minus 2, m minus 3, that is the factors from auxiliary equation. The same factor you can apply here. You have to write d minus 2d dash, d minus 3d dash. So this can be written as 1 by d minus 2d dash based on the roots d minus 3d dash of right hand side function y sin x, y sin x. Now you operate this factor first and then finally this factor here. Therefore, d minus 2d dash of 1 by d minus 3d dash of y sin x here. First operate this factor, then you can operate this one here. D dash. What will be the procedure here? You have to, if you have d minus md dash of this one, you have to operate integration. You have to replace y as a minus 3x. Y as a minus 3x here. Y sin x dx. Y sin x dx. You have to change y as a minus 3x. A minus 3x. With the help of this factor. With the help of the factor a minus this one, you can write y as a minus y only ought to give changes here. Now you change y as a minus 3x into sin x dx. Sin x dx. Now it will be like a product of two functions here. One is algebraic, one is sine. Therefore, apply Bernoulli's formula. You can apply Bernoulli's formula here, or integration by parts. Go integration by parts. 1 by d minus 2d dash. 1 by d minus 2d dash. Bernoulli's formula is uv1. U is a minus 3x. V1 means integration of sin x. That will be minus cos x. Minus cos x. uv1 minus uv1 minus u dash v2 plus u double dash v3, etc. Now u dash is minus 3. Okay, u dash is minus 3. U dash is minus 3. And v2 integration of this part. Okay, integration of this part will be minus sin x. Okay, minus sin x. Plus differentiation of this part is 0. Okay, differentiation of this part is 0. First you write two factors here, u and then v1 integration. Then differentiation of this one, integration of this one. Differentiation of this one, now 0 comes. Up to 0 you can proceed. Okay? Then after integration, you have to change a by y plus y minus y plus a as a y plus 3x. Because y is equal to a minus 3x. You have to change a by y plus 3x after integration. 1 by d minus 2d dash. 1 by d minus 2d dash. First write to minus plus everything here. Minus minus plus here, minus here, minus here. Now this a minus 3x as a y. Okay, a minus 3x as a y here. Therefore, this will be minus y cos x minus minus plus a minus here minus 3 sin x. Minus 3 sin x. That type of idea you can get. A as a y plus 3x or y minus 3x as a y minus 3x as a as a y minus 3x. Sorry, or a minus 3x as a y. A minus 3x as a y. A minus 3x as a y. For everything minus, I will take minus outside here. Therefore, minus 1 by d minus 2d dash of y cos x plus 3 sin x. Y cos x plus. Now, you have to operate this one here. You have to operate this one. For this, you can use integral. Integral y cos x plus 3 sin x. Y cos x plus 3 sin x. You have to change y as a. This is the factor a minus 2x. A minus 2x form dx. Wherever y comes here, you have to integrate with respect to so on here. Okay, so on. But in this integration, it is a separate integration. There is no y involved here. For this one only, you have to replace. This is a separate integration only. For minus integral y as a minus 2x into cos x dx. And this is separate integral minus 3 sin x dx. You separate the integration. Now again uv model uv1 minus u dash v2 Bernoulli's formula plus u double dash v3 minus etc. minus u is a minus 2x v1 is integration of this one is sin x minus differentiation of this one minus 2 integration of this one minus cos x minus cos plus formula plus differentiation of this one 0. That's all. Minus 3 differentiation of sin x will be minus cos x minus. Then after that you have to replace a is equal to y plus 2x. A is equal to y plus 2x or a minus 2x as a y. A minus 2x as a y. For a minus 2x as a y sin x minus minus plus again on minus 2 cos x and minus plus 3 cos x 3 minus plus 3 minus y sin x minus y sin x minus plus 2 cos x plus 3 cos x plus 5 cos x plus 2 plus 3 plus 5. This is your particular very simple picture. Therefore, general solution is CF plus PI. CF plus PI. Pi 1 of y plus 2x. Pi 2 of y plus 3x. Plus 5 cos x minus y sin x. Plus 5 cos x minus y sin x. Go on. Idea is very simple. Once again, repeat the procedure. Complementary function as usual. There is no different. The particular integral, the right hand side function is not in the form of previous 4 types here. Therefore, split into factors. Denominator is split into factors with the help of the obtained roots here 2 and 3. With the help of obtained roots 2 and 3, you can split into factors here. Then you can get d minus 2d dash, d minus 3d dash, that type of idea here. Then operate with the first factor here, d minus 3d dash y sin x here. The procedure is with this kind of linear factor, you have to integrate. You have to put the integral symbol and then y sin x dx integrate with respect to x, but we have to replace y as a, with the help of this factor idea, a minus 3x, a minus 3x. Correspondingly, a can be written as y plus 3x. Okay? That is the idea. Then integrate. After replacing everything in terms of x, integrate with the help of Bernoulli's formula. Product of two functions is here. Integrate with respect to Bernoulli's formula. Then you can get after integration, immediately you change a as in terms of y. For that, you replace a is equal to y plus 3x. Okay? Y plus 3 or a minus 3x as a y. Then okay. Therefore, you can get y cos x and so on. Now, again, one more factor is here, one more denominator factor is here. For that, also you have to operate integration. Integrate with respect to x this whole factor, but we have to change y as a with the help of this factor a minus 2x form, a minus 2x, and then integrate here. Then after integration, immediately you change a as a, you have to remove a as a y plus 2x or a minus 2x as a y. You can get the answer. This will be the idea. Very simple procedure. Very simple procedure. I think all of you understand this idea, this procedure. Do all of you understand or not yet? The same manner, you try one more problem here and give your answer here. Solve d square minus 4 d dash minus 5d dash square minus 5d dash square of z equal to 2x cos y equal to 2x cos y. Can you try in the same manner here? The same procedure. Yes, over. Problem over. Answer. Particular integral. Just use d minus roots are minus minus 5 into 1 plus 1. D minus 5d dash d plus d dash d plus d dash. Why you are getting very delay and for the answer? All of you here or not? Or trying or not? Don't have answer. Akash. Ashwat. Ashwat.
Sir, answer is 2 by 25
2 by 25.
of 5x cos y
5x cos y
minus 4 sin y.
minus 4. Okay. Okay, in the same manner, you have one more problem in this part here. Solve 4d square, 4d square minus 4d dash, 4d dash plus d dash square of z equal to 16 log of x plus 2. Right hand side is a different function, logarithm function. 16 log of x plus 2y. CF complementary auxiliary equation is 4m square minus 4m plus 1 equal to 0. Minus 4m plus 1 equal to 0. Then it will be 2m minus 1 whole square. It will be like 2m minus 1 whole square equal to 0. 4m square a square minus 2ab plus b square. B square equal to 0. It will be like 2m minus 1, 2m minus 1. 2m minus 1 or m equal to 1 by 2 comma 1 by 2. 1 by 2 comma 1 by 2. M equal to 1 by 2 comma 1 by 2. That will be the idea we can get. The roots are 1 by 2 comma 1 by 2. Therefore CF is equal to pi 1 of y plus of x plus pi 2 of x pi 2. Both are same roots here. Therefore x pi 2 of y plus of x. Your particular integral 1 by 4d square plus d dash square of 16 logarithm of x plus 2y. If you want to write this one in terms of factors here, if you take 4 as a common element, then you can write, suppose your equation is 2x square plus something equal to 0. Your roots are a comma b. Your roots are a comma b. Then it starts with the 2 means how can you write here? 2 into x minus a, x minus b. Roots are like that. Therefore here the roots are half here. Therefore you can write it as therefore if you take 4 as a common element, d minus half d dash into 16 logarithm of x plus 2y. This 4 and 16 get cancelled, therefore you take 4 as a anything. If you start with the 2 means you can write the roots with the help of the roots like this, x minus x minus. So 1 by d minus half d dash, you take 1 by d minus half d dash of logarithm of x plus 2y. X plus 2y. For this we operate integral logarithm of x.
Sir, 4 is in denominator or numerator, sir?
This is numerator. I am cancelling this 4 and 16.
Okay, sir.
Now for this factor operate integral with respect to x, but before that you have to change y as a, with the help of this factor. This is a minus mx form, a minus half x, a minus mx form, a minus half x dx. You have to change like this. Up to this, okay, right? Then that is equal to 4 1 by d minus half d dash integral logarithm of x plus 2y, a y now can be written as a minus half x, a minus half x dx, a minus half x dx. Now y can be written as a minus half x. Operate this 2 here. So 4 1 minus d minus half d dash integral logarithm of, this is x minus 2a, 2 get cancelled, minus x. For x get cancelled, only constant only. 4 1 by integral of log 2 plus 2a log 2a only, integral of log 2a dx, but this is constant. What you can get here, 1 by d minus 2d dash, your answer will be log 2a into x. This is integral. After integral you have to change y as a sorry, a as a y plus half x, I think that a as a y plus half x, a as a y plus half x, y plus half x. After integral, d minus 2d dash log 2 x is different, log 2a, a is y plus half x, a is y plus half x. Log of 2y plus x, log of 2y plus x. For 4, 1 by d minus 2d dash, d minus 2d dash of x log of 2y plus x, 2y plus x, x log of when you operate this one, you operate integral x log of 2y plus x. After this, you have to integrate with respect to x. What is the factor a minus of d minus of, sorry, of this of d dash. Or y as a minus of x, a minus of x before integral here. X log of 2y as a minus of x plus x dx. 2a minus x, 2 get cancelled, plus x. X get cancelled, so log again log 2a constant. Okay. Log 2a is constant, therefore log 2a x square by 2. Integration will be x square by 2. After this integral, you have to change a as a y plus of x. Y plus this 2 to 2 x square, 2x square can get cancelled, this 4. Log 2 a is now y plus of x. A is now y plus of x. Therefore 2x square logarithm of 2y of x is x, 2y plus x. For your particular integral equal to 2x square logarithm of x plus 2y. Particular integral equal to 2x square logarithm of x plus 2y. Okay? X plus 2y. This will be your answer.
Sir,
Ah,
sir, in denominator both are square terms, no sir. D
both
minus
are
1 by 2, d minus half d dash the whole square, no sir.
yes, yes.
Then we can make it as double integral, no sir. Both are same terms, no sir.
Both are same time, double integral okay, but after each integration, any manner both are same. After each integration, you have to change y by a by that one.
Sir,
That is
once we can change a to y, sir. Because double integral, because y is equal to a minus 2x in both the integrals, no sir.
okay. Both integral same thing. You see that
Ah, yes
here.
sir. For
Here,
y we can replace as a minus half to a half x. Then at last after double integral we can change a to y plus 2x half x, sir.
wait. I will explain. After this integral, okay. After this integral, log 2a. Okay.
Yes sir. If we take integral also same answer will come, sir.
Okay.
Instead of substituting a by y plus 2x, at last we can substitute after double integral, sir.
Okay. Okay.
Then also same answer will come, sir.
That's okay. But this problem we are getting this way. But other problems.
Sir, if we consider square term only, it will come, sir.
Okay.
If it is a square term, then it will come, sir.
Okay. Okay. Right. Right. Okay. Then one problem for your exercise. Your answer will be 2x square logarithm of x plus 2y. X plus 2y. One problem for your exercise that solve d square plus d dash square of z equal to d square plus d dash square of z equal to 8 by here you have to put some substitutions here, properly put the substitutions. And also roots are not in the real roots, you may get imaginary roots here, imaginary plus or minus I. So depends upon that you have to proceed. Okay? You can get imaginary roots here, m square plus 1, therefore m equal to plus or minus I. Based on that you have to proceed the substitution. Carefully you have to proceed. And the integration also can get some substitution idea here. Then only you can get the answer properly. Okay? Right. And this is for your exercise. D square plus d dash square of z equal to 8 by x square plus y square. Okay. Previous problem over for all of you. For all of you, previous problem you have to get the answer as a 2x square logarithm of x plus 2y. 2x square logarithm of x plus 2y. This is d square plus d dash square of z equal to 8 by divided by x square plus y square. Yes, with this problem, all the higher order PD of homogeneous type, different types, all the 5 types are over. 5 types are over. The next class I will give some more additional problems can solve under all the 5 types here. And we'll see after that 2 applications problem in the next class here. With the help of that first unit will be over here. With the 2 classes we can complete first unit here. Next to 2 classes. Okay, that's this session, and I have another class. If you have any doubt you can ask now, otherwise you can leave here. Okay, thank you for attending this